Hello! This will be the final chapter, I guess. So after 9. Sorry, not the final chapter. This is after the final. I've got more stuff to go and implant. So, this is a unique thing because I'm going to be copying and pasting a chunk of code. Now this is going to be a function that I'm going to be putting in. Now, when you're looking through your data, you've got your data frame. Now, there are some occurrences where when you're looking at your data and you're cleaning it, and let's say you've got thousands and thousands and thousands of rows of individual snippets of data, each with their identifying code, etc. However, when you're looking at them, let's say ages or sesquintile, etc., it is a good idea to go and look at their spread. Now you can just do a normal histogram, so spread to find outliers. Outliers. There we go. So ggplot. So let's have a look at our data frame. Aesthetics x equals AGY. Okay. Then we want to do histogram. Oh, you unexpected end of document. No, it's not. Lies and deceit. There we go. So, after this, we're going to be able to go and have a look at the spread of the information. And look, we've got some outlying information. So, some incredibly elderly individuals where, or maybe some individuals that may be difficult to go and deal with in data. Now, there's a good way that we can. I don't know why that's there. Let's just get rid of that. Let's put another one. Put another one in. Hopefully that'll work. Yeah, that works. So makes a bit of an issue, especially when you're doing statistical analysis. You've got outliers that are being annoying. And it's the outlier information, the extremes, that you may need to be worried about because they overlap and they extend your 95% confidence intervals, etc. So there's a chunk of code that's, if you have a look at, it's a nice big chunk of code here, and it's going to be called Outlier KD. Now I'm going to give you a chance, 5 seconds to go and copy all of this down. If I'm honest, this is all a little bit, I could probably explain it to you, but it would take a long time and I'd first have to figure it out myself. But it appears to work, and it's got quite a hefty reputation online to go and be pretty damn decent. So, I'll give you 5 seconds. 5, 4, 3, 2, 1. Okay, now I cannot remember the actual name of the person, so I should go and I'll go and reference the person who actually created this, because this is not my code. However, it is very, very useful. So let's go have a look at this, and let's first of all make a data frame 1, which is exactly equal to the data frame, so we're not overwriting stuff, because this is interesting. So we're going to go Outlier KD. We're going to put our data frame in. So let's do data frame 1. Let's have a look at AGY. Let's have a look at this. And what this shows, first of all, it goes and gives a nice little script at the bottom here. And it goes and gives you some box plot charts with histogram next to it. So essentially what it's doing is providing a box plot first with the outliers, and then another one without, with the with the additional histogram next to it. And this shows a nice, a bit of a smoother line as well as a, well, a better box, essentially. And it goes and gives you the option. So you have a look at this. It says outliers identified. The number proportion of outliers is 0.6 to the mean of outliers. 82.33 without removing outliers. A bit of information behind it. Now, it also goes and gives you the opportunity to take them out. Do you want to remove the outliers and to replace them with NA? Now, age is a bit of a rubbish thing. Maybe you've got just an extreme, I don't know, temperature that actually means that the person is actually technically on fire or steaming out the ears or something like that. And it identifies things that are obviously extreme. You can't really be looking at. Now, if I put in yes here and type it and just press enter, it says outliers successfully removed. Now, let us next up have a how did I do this last time? All dot equal. So let's do all dot equal, which is a base package. We can put our data frame, which is our original one, and then our data frame 1. And we can have a look at them directly. Sorry, get off that. There you go. We can have a look at them directly. So let's have a look. It says rows in X but not in Y. That's fair enough. It says this are different because they're exactly the same thing. But it means you can go onto 480. Let's go on to 480. Okay, it's not, doesn't want to load the full amount. That's annoying. Oh. Yes it does, sorry. That's HHID. So 480. This case, as a person, that is 93. That's of the extreme. So it's just a bit of a way to go and have a look at some of your extreme examples. Age is probably a bit of a useless thing to go and take out of it, but maybe useful to go and take it out in some instances. If we have a look at data frame 1, and we have a look at the same thing, so 480, row 480, we can have a look to see 480, where's 480? Ah, there we go, and that's been replaced with NA in this context. This woman who was between 61 and 100, she was 93, I believe. So it's just an interesting thing to go look at. I'll leave it at that. Over and out.